Hello, my name is Jason Hogg. I'm a program manager in the Microsoft Azure Storage team. I'm going to talk to you today about monitoring, diagnosing, and troubleshooting Azure Storage-based applications. While the implementation specifics of what I'm discussing are relevant to storage, many of the concepts are relevant to all of Azure's workloads and, in fact, most distributed applications. As people may know, Azure Storage is a platform, and we have 5 different products that we've built on top of that platform. Blob storage, which is useful for storing images, videos, backups, that sort of data. Table storage, which is our NoSQL key value store. Queue storage, which is useful for decoupling components within an application. File storage, which is our SMB fully managed share, which we're extremely excited to announce is GA as of today. And disks and premium storage, which provide the persistence mechanism for all of Azure's virtual machines. My goal for today is to prevent this person from ever entering your office. There's nothing worse than having a customer or your manager enter your office and inform you of a challenge with your application, either before you're aware of it, or for you to be in the situation where you're not sure where to start looking in terms of diagnosing or troubleshooting the specific issue that they're describing. So with that in mind, my objectives for today are to actually review the need for monitoring, diagnosing, and troubleshooting to be thought of during development. Secondly, for you to fully understand the end-to-end monitoring capabilities that Azure Storage provides. I also want to make sure that you know where to start looking when you have to actually diagnose issues. And I'm going to spend quite a lot of time demonstrating how you can use storage analytics and some tools like Message Analyzer and Fiddler for helping you diagnose and troubleshoot problems. I have pointers to all of the resources that I use in this presentation at the end of the deck. So why are you monitoring? First of all, if you're running a business, you've probably got business KPIs that your application needs to meet. Secondly, if you have customers, you've probably got service level expectations that they have, that they want you to meet. So you're typically thinking about service health, availability, performance, scalability of your application, capacity, those sorts of things. There's 2 different ways to actually look at monitoring an application. First of all is inside out. This is where the components within your application are all instrumented, and you've got alerting mechanisms such that if any one component has an issue, you can actually start to drill and actually diagnose. Secondly, there's something called outside-in monitoring. This is where you basically, from outside of your application's network, you want to simulate synthetic transactions similar to what your customers' applications are performing, such that you can determine what their experience is like. For today, I'm focusing entirely on inside-out monitoring. So the Azure Storage Service has 3 different types of capabilities that you want to be aware of for monitoring your application. The first is called metrics. Think of these as perfmon-like counters that actually allow you to understand all facets of Azure Storage. We also have alerts, whereby you can basically define thresholds for specific metrics, such that if they're exceeded, you or your administrators can be alerted. If an issue does occur, and you can't troubleshoot it just by looking at the metrics, often you may need to drill into logs. So that's where we've got the ability to log every single REST API request if you want to. Now, if you're building a client application on top of storage, our storage client libraries also include configurable tracing information. And oftentimes, if you're actually trying to troubleshoot a network-related issue, maybe a performance issue, you may also want to be using network tracing tools, such as either Fiddler, Message Analyzer, or Wireshark, depending on whether you're actually tracing at the HTTP layer or at the TCP layer. One of the challenges that you would find is if you're actually pulling data from different sources, say storage logs, client libraries, your application, and network, the challenge then becomes how do you actually pull all of that data together? Well, the good news is we've got a correlation identifier that the client libraries established that is passed from the client application across the network and into storage. And that actually allows you to actually correlate requests across the application and storage. We've also built tooling that I'll be demonstrating shortly that will allow you to import all of this data and actually filter it and look for patterns within the data, thus making some of the actual work that you would have to do. Typically, you'd have to look at the guide, read the guide, look for the patterns. We've defined many of those in Message Analyzer to make your lives easier. There's several situations where you may actually need to actually start diagnosing. The first is where your metrics data is actually showing maybe an alert that you defined as showing that you've actually exceeded the baseline estimates or values that you had established. Secondly, maybe your application's crashed for some reason. Thirdly, reports from your users that something's going wrong. Or from looking in the log data, you're actually seeing some errors occurring that you want to look into further. One of the things you really do want to keep in mind, though, is that you want to actually start understanding how your application behaves during development and testing. Sometimes if you wait until production, it's very difficult to know whether the values that you're seeing, either in metrics or in your log files, are based on your application's behavior or specific issues that you want to drill into. On the right-hand side, you can also see a troubleshooting decision tree. This is where our experiences from interacting with thousands of customers, internal and external, we've captured and documented in a monitoring and troubleshooting guide. And what I want to do now is I'll just drill into one topic that we see occasionally, which just sort of demonstrates some of the information that's inside that guide. So oftentimes people build applications that run on top of storage. They may encounter a performance issue. And it's not clear to the end users how to actually determine whether the issue is to do with storage or whether it's to do with network or the client application. And there's two specific metrics that are very useful for troubleshooting this situation. The first is average server latency. Average server latency is the time it takes for Azure Storage to actually process your request. Then there's average end-to-end latency. This includes not just the time that storage is actually running your request, but it also includes the time that storage takes to read your request off of the network and the time it takes for us to send the response back to your client application. So you can see, obviously, the average end-to-end latency includes time spent in the client application, time spent on the network, and storage. So a couple of good examples from the guide I mentioned earlier for how these two metrics can be useful. If you're actually seeing high end-to-end latency and low average server latency, then maybe that means you've got a slow network. Or potentially it means you've got insufficient client resources. Similarly, if you're seeing low average end-to-end latency and low average server latency, then it potentially means you've got an issue in your client application that you want to drill into. And that's again where a combination of the server logs and your client logs can be very useful for troubleshooting. For the rest of the presentation, I want to actually jump into hands-on mode. I'm going to show you how to enable metrics and logs if you haven't already enabled them. I'm going to show you how to diagnose a very simple error. Then we're actually going to drill into a more complex error, which requires you to look at storage logs, network logs, and application logs. Finally, one other request we get from our customers a lot is how do they actually simulate exceptional conditions which are server-side when obviously the server's outside of their control. So I'm actually going to show you some tools that actually allow you to simulate server errors such that you can test how your application responds to those errors. So to start with, what I'm going to do is open up the new Azure portal. This is the new management portal that we've built. And what we've done is I've created a tile just for the storage account that we use for this demo. At the top of the storage account, you can see the different storage objects, containers, queues, file shares, tables. The first thing that we want to do is go into settings and ensure that diagnostics is enabled. By default, diagnostics, both metrics and logs, is actually disabled, although we are working on enabling metrics by default because we think it's such an important mechanism for customers to have access to. So the first thing you want to do is, if this is turned off, turn it on. You've then got the option of enabling metrics and logs. By default, once you enable metrics, we basically create summarized versions of your metrics at both 1 hour and 1 minute intervals. 1 minute is very important once you basically isolate a specific issue and you want to drill in. We also have at the bottom log files. You can enable logging for blobs, tables, and queues. Now, logging does actually take up a reasonable amount of space. So one of the things you do want to think about is a retention policy, such that your blobs, tables, or queue logs will be deleted after some period of time. Right now, I've got it set to 90 days. You obviously want to make sure that the maximum period of time within which you might have to troubleshoot an issue that a customer had, you've got the data retained for that period. Okay, so now that we've enabled metrics, what you will see is a monitoring capability start to appear underneath your storage account. And so there's a couple of different graphs. The first one we'll actually drill into is just this high-level graph, which is basically showing us the number of transactions or requests that have actually occurred against our blob, table, and queue storage. I mentioned earlier, we're working on metrics for files, and that should be coming in the next month or so. What we can do, which is quite interesting, is, or where things get interesting, is we can now actually edit the chart. And there's a couple of things we can do. To start with, you can see right now we're looking at a very high-level summary of the interactions that we've had today. So maybe the first thing we'll do is let's change this view so that we're looking at requests over the past hour. And so this is, again, another good example of how we can actually start to drill in. So you can see there was a specific peak in traffic at a certain point in time. So that's kind of interesting. The other thing that we can do is From a high level, remember I talked about the fact that there were 40 different sort of metrics. Underneath blobs, tables, and queues, you can basically go and enable different metric counters to be visualized. So for example, we can determine the number of authentication failures, we can track the availability of your service, we can track latency, capacity, the percentage of successful requests, a whole number of things, all of which are very useful for you to actually understand how your application is performing. So let's take a look at, so we've taken a look at the daily versus the hourly. Here's another graph that's already displayed where we can see average server latency for blob storage, I believe in this case. Now again, as we sort of talked about, server latency is kind of interesting for seeing how storage is performing. But what you might also want to do is get an understanding of the end-to-end latency. So let's go and enable that counter. Press save. And now what we'll see in the graph is both the end-to-end latency and storage's latency. So that's where you can basically see, hey, the purple is basically storage's latency. End-to-end latency for green is kind of high relative to storage. What you probably find there, these are actually blob requests. So it's probably the actual uploading and downloading of the binary data that I was sending. But if you wanted to drill in further, that's where you could basically then go and start looking inside your storage logs and have a look at the specific operations and start to see if there's specific operations where end-to-end latency and server latency are pretty close and other operations where it's not. And the ones where there's a gap, you might want to investigate. Before we take a look at storage logs, there's one more capability related to metrics that I want to make sure that you're aware of. And that is this alerting infrastructure. So obviously having metrics is great for allowing you actually to sort of monitor on an ongoing basis the health of your system. But quite often what you want to do is basically create alerts that basically allow you to actually monitor your metric data and alert you should something go wrong. So what I've done right now is just created a very simple report or alert, which is basically where if your end-to-end latency exceeds 1 second for more than 5 minutes, it's going to send you an email. And it's going to send it to your administrators, and in this case, it will send it to me. So again, a great capability there for actually proactively notifying you that maybe something's going wrong and that you should actually take a look. So we talked about metrics, we talked about alerts. Now there's a couple of reasons why you might want to start looking at log files. The first one I mentioned was, as we described earlier, if there was a gap between the end-to-end latency and server latency, maybe you want to start looking at the underlying log operations. Another example where logs could be really useful is if you wanted to verify that a specific operation had actually succeeded. A good example of that is, let's say one of your customers calls up and complains that some of their data has been deleted, and they're actually claiming that maybe your application wasn't working properly. There's a great example there of where you could look in the storage logs and try to actually determine what had actually happened. Now, as I mentioned, log files are similar to sort of IIS log files. They're text files. I've got an example of one right here. They've got an awful lot of information, and they typically contain an awful lot of rows of information. Kind of hard to actually use from Notepad, though. So that's why one of the things that we've done is spent time working with the Microsoft Message Analyzer team. Message Analyzer is the successor to Netmon, the old network monitoring tool that Microsoft used to have. What Message Analyzer allows us to do is analyze data from various sources. It can actually take a network trace if we want to. But in this case, what we've done is actually created parsers such that Message Analyzer knows how to parse Azure Storage's log files. So let's take a look. So I'm creating a new session. In this session, I'm going to actually retrieve log files. I'm going to retrieve them not from the local file system, but I'm actually going to take them from Azure. So it's going to connect directly to my test account. So what I'm going to do here is basically go back to storage. I'm just going to grab the keys. So I've copied that. I'm going to paste my storage account key in here. And you can see we've now established a connection with my test account. You can see all of the log data is actually stored inside a $log folder, which if you try to look at blob storage from Visual Studio Storage Explorer, it's actually hidden. You won't see it. But from within Message Analyzer, we can see the log files for blobs, queues, tables. We can actually drill in 2015. Now, in this case, let's assume the customer was able to actually tell us roughly the time of the day where they actually started noticing that the data went missing. We can load, select all of the log files that sort of occurred during that period of time. And Message Analyzer is now loading these and concatenating them together. which again would have been a challenge if you're trying to load these log files into something like Excel. It's kind of a pain to actually do that, combining them together. If you didn't know the time period, you could actually load a lot more of the log files together, and you could actually write a filter in here to actually reduce the size of the data that ends up getting visualized within Message Analyzer. So I'm going to press start. Now what you can actually see is we've basically loaded 2,500 log files into Message Analyzer. And the first thing we can notice is there's a default view right now. So what we want to do is actually change the view so that it's actually using the view that our parser actually has generated. So you can actually see here are some key columns from storage as logs. You can see a timestamp, you can see the specific HTTP method that was actually used, the client request ID we talked about earlier, some latency information, the status code. There's also an awful lot more information that you can actually get. If you double click on one of these rows, you can actually see, here's the full set of data. Here are all of the columns that we store in our log files. One specific piece of information that might be useful in this case is the requested URL. So I'm actually going to click on that and say, add this column to the list of data that we're viewing. And I'll actually drag this over here and shrink that view. So what the requested URL is going to be helpful for us. Let's say if the customer is actually insistent that the specific file that went missing, so I'm going to type the request URL, contains a string. Let's say that the customer can't remember the exact name of the file, but they know that it actually contained backup. So we're now going to actually filter the data, and we've gone through the 2,500 rows and basically brought back 4 different responses. And you actually see at this point there was a put blob operation, which is probably when the backup data was actually loaded. There's a get blob. Maybe at some point we tested the actual data to actually see if it was there. But this is where things get interesting. At some point, somebody deleted the data, which is why the 4th time somebody tried to actually retrieve the data, they would have got back status code 404, meaning the object's no longer found. So what you could do if you're troubleshooting, you could drill into the delete blob operation. You can see at that point it was actually an authenticated request, and you could actually even see the IP address that the actual request originated from. So that might help you, first of all, confirm that the data was actually intentionally deleted, and secondly, help you maybe potentially determine who or what application actually deleted the data. So that's a very simple illustration of how Message Analyzer can actually help you. I'm going to show you a more advanced example of how Message Analyzer can be useful, where we actually need to actually correlate information not just from storage logs, but from the network and from client applications logs. In order to actually explain what I'm going to do, I first want to explain one of the APIs that occasionally people have challenges with storage is when you're creating a container. So for anybody who's used our .NET libraries, you might have seen this in the past. When you create a container, which is of course the organizing construct that you use for storing blobs, we have an API called create if not exists. What this does is determine if the container that you want to create already exists. If it does, it doesn't do anything. If it doesn't exist, then it will create the container for you. Now, there's one situation which is not intuitive, whereby you actually may call this API and you get back an HTTP 409 with not a lot of information to actually help you understand why you're getting a 409. So let's assume this occurred, and let's assume that for the sake of expedience, you turned on Message Analyzer's network logging capability. You also enabled logging within the client application, and you went and actually downloaded your server's log files such that we could load them into Message Analyzer. So what we're going to do is, again, create a new session. At this point, I'm going to go to File Explorer because I've actually I have saved my logs, demos. And what I'm going to do, there's 3 different types of log files that I'm going to load. First two I can load together. The first one you saw was actually called client application log. So this is if you've enabled logging in your client application, what you want to do is change the default parser such that it's basically client log files. The second one that you see here, end-to-end logs, this is basically Message Analyzer was doing network tracing while the application was running. So we've got the network trace, we've got the client trace. Now what we want to do is actually import all of the storage logs. So this was this could be over a reasonable period of time. So I'm going to grab all of those, select them, and open them. The parser is obviously the storage log file parser. Again, if you had a massive amount of data, maybe over weeks or something like that, at that point you want to start filtering either by time or writing a specific filtering condition. Maybe if you're looking for HTTP status or something like that, you specify that. That would actually reduce the amount of data that you were searching through when you start the diagnosing phase. So now I'm going to press start. Now what's going to happen, second session is established, all of the data has been loaded. The first thing we want to do is actually just, let's group the data by module. So this will actually show us that the client logs, there were 1,450 messages that we loaded, our storage logs, 270, and from the network trace, 148 different requests were logged. So that's kind of interesting, and you can actually see we can drill into our client logs, for example. This is the data that would have been emitted to your local file system if you'd enabled logging within your client application. Again, you're still sort of searching for a needle in a haystack at this point. So one of the things you can do is actually change the view. And in fact, you can now group the requests by correlation ID. So this is actually very useful for actually combining the actual client, network, and server logs together. Now, for the sake of this demo, what I'm going to do is assume you've been debugging. And what we're going to do is actually search for, basically write a filter that's basically going to filter all of the data that contains a specific client request ID. So this is basically where if you'd encountered this 409 error, you basically, in debug mode, get the client request ID back, apply this filter, and we've basically gone through and it's actually filtered the client logs, the storage logs, and the network logs to actually determine which were the messages that basically have that correlation ID. You can basically then start to look through the client logs. You can see basically all of the different data that we output. But where things get kind of interesting, you can also look obviously inside the storage logs. And this is where that one API, you can actually now tell, that one .NET API actually contains two different requests from a REST perspective. The first is where we call get container properties. And if that exists, then it obviously implies that there's a container there and we don't need to actually recreate it. In this case, though, it did actually return a 404, meaning that container doesn't exist. So therefore, you'd want to create the container. But in this case, we call create container, and this is where the client library did this work for you. But a 409 was returned. So there's not a whole lot of information that's actually there for actually helping you within the actual storage logs. So let's take a look at what went on the network. So again, on the network, there's two different requests occurring here. One will be the actual get container properties. The second one will be create container. Let's drill into the create container operation. So you can actually see here where there's a create container. And what's kind of interesting to see here, here's the put operation where we're trying to actually create the container. And here's the response. And in this case, we've got basically the 409 back, but it's actually telling you a little bit more information. The specified container is being deleted. Try the operation again later. Fantastic. That's actually very helpful. So what's actually occurring there is in storage, when you actually create a container, if you then delete the container and then try to recreate that container shortly thereafter, it may be that our garbage collector hasn't yet kicked in and deleted that container fully, at which point you can't recreate another container with that same name. So that's actually the issue that we've encountered. So you can see there where by actually searching through an awful lot of data and actually then being able to actually correlate the actual client request and the storage request and the network request, we've been able to actually troubleshoot a specific scenario. Let's actually remove that filter. I mentioned earlier as well, one of the things that we've done is that guide that I referenced has a number of different sort of proven practices, different patterns that you can look for in the data. What we've tried to do is encode many of those in this library. So for example, if you're looking for deleted operations, we've got a simple filter there that will help you. If you're looking for conflicts, such as what I just described, you could use this condition. If you were looking to actually filter data based on a time condition, we've included some data there. Client other error. Basically, we've got a large number of different sort of filters that you might want to take a look at, just to actually help you as you're performing the actual diagnosis. Maybe it saves you a little bit of time reading the guide. But over time, you can also you can extend this library to actually include specific conditions that you're looking for. One of the situations that we hear from developers is where they want to be able to simulate error conditions that storage service may actually provide. So a good example of that is we have scalability targets to define different thresholds whereby we can actually sustain a certain number of traffic or a certain amount of bandwidth. And if you exceed those, you may get throttled. But it's very hard for you to actually deterministically create that situation. So what we do want to do, though, is ensure that we're testing for that during development. So I'm going to walk you through now an example of how you can actually simulate server-side faults such that you can test your application's behavior. So we're going to open up Visual Studio. And if you've installed the Azure SDK, within Visual Studio, there's a set of samples that are really great for getting started. They're also good for demos. So if we go File, New, within this Templates folder, there's these quick starts. I'm going to select the blob quick start. The nice thing about these quick starts is that they have great documentation, provides an overview of what the quick start does, how to run it, and how to basically pointers for additional information. The first thing that we're going to do is actually modify the actual configuration. By default, these quick starts, the storage quick starts, will run against the storage emulator, which is very useful because you don't need to type a credit card, you don't need an Azure account, anything along those lines. So let's actually just type so all I've done now is updated the actual connection string with my storage account name and the key. Now, the second thing we'll do is just quickly go through the source of the application. It exercises both block blobs and page blobs. For the sake of this demo, we'll just comment out the second part of this. Just build, make sure that it actually works. So it looks like the application is running. Now what I want to do is open up Fiddler. So Fiddler is actually another network tracing tool that allows you to not just intercept requests, but it also allows you to actually modify those requests. So now let's run the application. And you can see that we're actually creating a container, uploading a blob, listing all of the blobs within a container, and then deleting the blob. If we go back to Fiddler, what's great is you can actually now see it's intercepted a bunch of HTTP requests, which basically, the first one is basically where it's checking to see if a container exists. Container doesn't exist, so it basically then creates the container. You can then basically see the actual request for all of the objects within the container, and I think you can actually see a list of all of the blobs returned, that sort of stuff. So again, this is actually a great capability just for troubleshooting in general while you're building your application. But where Fiddler gets even better is it's got this scripting capability, which actually allows you at different points to change the, essentially simulate server-side conditions. There's two conditions that I think are particularly interesting. One is where if you wanted to actually simulate like high latency clients, maybe mobile applications, those sorts of things, you can actually enable the setting called simulate modem speeds. So you would set that setting to true. Then you could in here basically define what kind of latency you want to introduce. We're not going to focus on that so much today. What we're going to do now, though, is simulate a data center failure. So what we're going to do here is essentially, I wrote the logic earlier where we basically save the script. So at that point, oops, let me just go back to the code. What you can see here is basically we've written some logic that basically allows you to search for requests where the host name comes from jahogtest3.blob.core.windows.net and where the URL, path, and query contains hello world. In that case, what it's going to do is rather than sending the request to storage, which would then return the actual object that you've requested, it's going to return a 503, which is actually the same response that we would actually return if you were being throttled. So this is actually a great test of whether you're being throttled or not. So now actually what will happen is if we run the application, you're actually going to say we're able to create the container, but when we actually try to upload the blob, what you're going to see is inside Fiddler, you actually see the first operation where we created the container. That was successful. But the second and third, fourth, and fifth operations, it's actually intercepted the request. It matched the pattern that we defined. And instead of going up to storage, it's actually returning 503. So a great way to actually test how well your application behaves under that condition. And you'll actually see our application didn't behave very well. And so what actually happened, the reason that actually multiple requests were generated was the storage client library will automatically try to request this type, will retry this type of operation. It uses an exponential backoff capability, which is why it seems a little bit slower for each of the following requests. So this is actually, the Fiddler script is just a great capability to enable you to simulate conditions which are outside of your control, but still ensure that your application is able to actually manage those appropriately. So we'll close down Fiddler, close down Visual Studio, and go back to our slide deck. So to close off, got top 10 recommendations that we'd like you to be thinking about. First of all, during design and development, think about operations. Understand how your application performs in your test environment. Start to establish metrics and rules that would allow you to actually then establish policies when you go into production and know whether something's going wrong in advance of your users reporting the issue to you. Definitely enable metrics and logs, both in your testing environment and your production environment. Think about simulating server-side errors where those error conditions are possible. Select the right resource for the right task. This is something that we see occasionally where people actually have used table storage when they could have used blob storage, those sorts of things. We have good guidance available now. I've got pointers to those shortly, so definitely take a look at those. Scalability targets, we publish what our upper ends are for how each of our services perform and what scalability targets we deliver. Understand those and design your apps with those in mind. If you want high availability, RAGRS can allow you to actually have 4 nines read availability. We have great design guidance now, both scalability checklists and design patterns specifically for table storage. Make sure you're reading that if you're using either of those services. And once again, design for operations. And to close, I wanted to provide a quick summary of the different guidances available. We do have a hands-on lab that walks through using analytics, AZCopy, and Message Analyzer. We also have great guidance now for monitoring, diagnosing, and troubleshooting storage that I referred to earlier. We also have scalability performance design guidance, plus design guidance for table storage. You should definitely make yourself familiar with. So with that, wanted to thank you for your time. And if you do have any questions, feel free to reach out to me at Jason Hogg on Twitter. Thank you.